Okay, Assalamualaikum. So today we're going to continue to the next chapter, which is chapter 3, with the topic of user-defined functions. Okay. So first, I would like to show you the overview of the chapter. Okay, so we're going to cover all these topics in this chapter. Okay, so first we're going to revise what is the script files. Okay, and then introduce you about the basics of the user defined functions and also the function files. Okay, after that we're going to see the structure of a function file and how we can use, or most definitely I will use the term calling atau call these user defined function files. And then we're going to look into anonymous functions, the use of sub-functions and nested functions, and finally the example of user-defined functions. So in the first part of this video, we're going to cover how we can call or use the user-defined function. Okay, so the rest will be covered in the next video. So let's revise a little bit. Okay, so previously what you have been done, okay, the calculations and all the programming, okay, you probably remember that we have do it example or some calculations in the M file or text editor. Okay, that is called as the script files. Okay, so the script files contain many lines of MATLAB expressions and assignments. So if you remember the way that I have shown you previously, that I demonstrate a few examples of calculations. Okay, so that's calculation. We did that in the M file, so we call it a script file. So script is basically a sequence of MATLAB instructions that is stored in a file with an extension of .m and save. Okay, so whatever programming atau coding yang you type in, lepas tu you save dalam that file editor with extension .m is called script files. You can execute the script files, or normally kita panggil dia as run the files, by entering the name of the file. Okay, so you boleh type in file name without the m.m extension to run the script file. Okay, that's about script files. Okay, and then we're going to move to the kena tahu that in MATLAB there are two major types of functions. Okay? The user-defined functions and also built-in functions. Okay, so what's wrong? You might be asking, why kenapa dia ada beza user-defined function and MATLAB built-in function? Okay, the built-in function tu as if what you have been done previously. For example, yang kita nak guna plot. Okay, dalam plotting chapter kita guna the plotting command. Okay, so the plot command is an example of a built-in function. Okay, so although MATLAB has a number or a variety of functions that is built into the MATLAB, okay, sometimes we might need a function that is not provided by MATLAB. So guess what? You can write your own function or your own programming language, and then you can use that function or your program just if they were built into MATLAB. Okay, so far so first let's take a look about the definition of functions. Okay, Okay, so functions can be defined either as a separate files or at the end of a script file. Okay, so this in the current or latest version of MATLAB, I believe it 2017 and above version of MATLAB. So if you are using 2018 or 2020, you can define your function line, function file either in a separate files or at the end of a script file. The function files have to be defined in a separate file. It cannot be included at the end of a script file. Okay, otherwise MATLAB akan issue a warning error. Okay, so the important part, okay, the major part yang I need you to pay attention and understand is how the function structures. Macam mana you nak type in the functions. What are the structures of the functions? Okay, because it plays a very important role in this chapter. So, a function, okay, as the part of the definition, consists of the function definition line, a function body, and also the end command if the function is within a script file or if it's a nested or sub-function. Okay, we're going to look more into it as we proceed into the chapter. Okay, why you use functions in programming? Okay, so there are several reasons. Okay, why you use functions in the programming? Okay, so for example, okay, in executing a programming project, okay, sometimes you might have a complex task. Okay, complex task means you maybe need more than 2 lines of MATLAB program code that you will reuse in a few or function in one separate files. Okay, and then you boleh write your own script file and then you boleh call that function files, okay, from a new script file. Okay, so it basically dia macam you divide kan. Okay, for example you ada 1000 ke 100 lines of code, okay, MATLAB code, and then you divide the okay into a separate reusable function file. Okay, so if you ada satu project yang ada few function, okay, you boleh divide. Okay, function A, okay, so part A ni, okay, one person will in charge of part A, and then for example you ada satu team yang consists of three people kan. Okay, that 3 people will have access to that function file, and then you boleh look into, if they interested, you boleh look into how depth you punya coding program tadi. Okay, so it is reusable. Bila you dah divide that function into several function files, it makes MATLAB run faster. Okay, so when you need to execute that few function files as one whole project, you can just call the function. Okay, so it is easier every time you nak execute that task. Okay, kalau sebelum ni saya ada tunjuk you example what's the difference when kita guna script file tu, as in kita buat kita punya calculation from the script editor and also from the command window. Any mistakes, okay, with command window you have to re-enter and retype every time kan you nak buat change. Okay, but with script editor you boleh just directly adjust or modify you punya coding tu without the need to every time nak betulkan dia kan, right? And then basically, Okay, bila you dah break down that huge program task into a collection of smaller tasks, okay, it is easier to design, write, debug and maintain the code. Right? Now, let's take a look at the structure of a function file. So, before we jump into MATLAB, okay, we are now going to take a look at the structure of a user-defined function. Okay, so here, okay, in this blue line box here is an example of a syntax, okay, ataupun structure of a MATLAB function. Okay, so it consists of the first line here is what we call a function definition line. Okay, so this function definition line contains the function inputs. Okay, this is the inputs and also the function output. Okay, args here means arguments, so input arguments and output arguments. Let MATLAB know that you are creating a function file. Okay, and then this green colored font here are the comments. Okay, the comments is not a really what do we call it? It's not really compulsory, but it is a useful section for documenting the purpose of the function as well as input and output arguments. Okay, so I highly recommend including the comment section, particularly if other users might use your developed function in the future. Okay, now let's look at the output arguments and also the input arguments. Okay, if you can see here, the output arguments are enclosed in the square brackets. Okay, this is the square brackets. Okay, while the input arguments are enclosed inside the round bracket, or we call it the parenthesis. Okay, the function name, okay, this is the function name, is the same name that the file will be saved as. Okay, so this is the basic syntax or basic structure of a MATLAB function. Okay, so let's take a look at this example here. Whether they are built-in functions or user-defined functions have similar syntax. Okay, this is the syntax of a cos function. Okay, cos ni is a type of a built-in function. Okay, so it consists of a name. Okay, name is the cos. Okay, name ni maksudnya cos. Input. Okay, input here is this one, the x variable inside this round bracket, and also the output. Output here is the variable a ni. Right? Okay, so sometimes we call output arguments as output variables and also input arguments as input variables. Okay, maksud dia sama. Right, so here is an example of a MATLAB function file. Okay, so I repeat again that all user-defined functions must start with a function definition line. It is a rule, okay, where you must follow. Okay, so what the lines, okay, what are the definition line means. Okay, first, must start or must have the word function. Okay, and then it should also consist of a variable that defines the function output, the function name. Okay, so here, okay, on the right part of these slides, okay, you can look at this example. This is an example of a polyfunction. Okay, this is how, if kita nak represent this polyfunction in a diagram here. So we have yang kotak biru ni is the function poly. So this is where the input arguments, okay, x, is passed through the poly function, and then output argument or output variable will be produced. Okay, so output dia adalah, kat sini nama dia output. Okay, so this is an example of a simple function which only consists of one output and one input. Okay, notice that the function file should start with the word function. Okay, and then the output variable should be enclosed inside this square bracket. Okay, and then you should have your function name. This is the function name. Okay, so the function name should have similar name with the file name. Okay, so bila you save you punya function file, okay, you have to save it using the function name. Okay, you tak boleh tukar. Okay, and then right after the function name, you have the input argument, or we also call it the input variables. Okay, so in this case, in this example, the output argument only have one. Okay, while the input argument have one also. Okay, ni salah ni, they should have a one. The function has one. Okay, so this is how you type in the function line into your MATLAB. Okay, so here there are several types of functions. Okay, the first one, or we call the simple function one, is the function that only have one in and one output. Okay, so here are the definition of the function declaration line or function definition line. Here is the correct expression and statements that compute the output variables using the value of the input variables. Okay, so here, for example, how you nak choose you punya function names. Okay, make sure that you use meaningful names. Okay, which means that select names that tell you something about what your function does. Okay, and if you want to create a user-defined functions, do not use a built-in names. For example, like square root, sqrt. Okay, do not use this term. Okay, because all these are built-in. Okay, dia dah ada dekat dalam MATLAB tu. Okay, so tak perlu repeat the names. Okay, so there's a way where you can check whether a name is already in use or whether it is used in the built-in function. Okay, there's a way I will show you now. Okay, so let's open our MATLAB. Okay, first I'm going to clear the screen. Okay, so I have cleared the screen. So the most important part when you nak guna function file ni is, okay, that function file or script files tu, okay, should be in your current folder. Okay, so first specify your current folder dulu. Okay, so nak specify, okay, notice that there's a little folder that is for browsing. Okay, so you boleh browse and then you boleh choose whichever folder that you want to specify as the current folder. Okay, function of the current folder ni, all you punya script and function tu dia akan save dalam current folder tu, and then you boleh execute. For example, okay, kalau you tengok kat sini, I have an example 1. So I boleh example 1 ni, kalau you tengok, this is a script file. Okay, so I boleh run dia, okay, provided that I have this file inside my current folder. So I boleh call example 1 kat dalam file tu. Okay, let's clear. Okay, I'm going to show you first how, okay, this is how you can check whether a name is already used for the built-in function, or whether a built-in function name for that, for your chosen name to is exist. Okay, you can just type help exist from your command window, hit enter. Okay, and then you can check. Okay, this is how you check if variables or functions are defined. For example, you type in exist and then dekat dalam ni is whatever file name. Okay, 0 if A does not exist, if is a variable in the workspace, and then tu here dia punya maksud je lah. Okay, so for example, okay, you boleh type exist poly. Okay, the answer is 2. Okay, 2 ni maksud dia it is an M file on MATLAB search part. Okay, it also returns 2 when A is the full part file, or when A is the name of file, M file name. Okay, it's not a built-in function. Okay, let's try a built-in function, exist sign. Okay, so dia return 5. So 5 is a built-in MATLAB function. Okay, so please do not use that sign tu as you punya function name. Okay, so let's clear this command window and workspace. Okay, let's get back to our slides here. Okay, so you can create function file. Okay, because I use the version of 2015, you can only create function file in a separate editor file. Okay, so that means I can only open, okay, create. Okay, nampak sini ada script dengan function. Okay, you boleh create function file. Okay, so bila you choose the function file, okay, yang ni dia dah ada dia punya preliminary punya template lah. Okay, so kalau nak create function file, dia kena ada function. Okay, and then whatever you punya output argument tu should be enclosed dalam this square bracket. Okay, for example, I want to show you the output. Okay, And then this is title 7 ni is the file name. So let's try this poly. And then to describe whatever the function is all about. So this function calculates the value of a third order polynomial. Okay. Yang ni kalau panjang sangat, so saya boleh letak kat bawah ni. And then now kita define whatever calculation yang kita nak buat tu. So 3 multiplication x to the power of 3 plus 5 multiply with x square minus 2x plus 1. Okay. Sekarang next step is you gonna save this function file. Okay, save. Okay, so bila you tekan save, dekat file name ni dia automatically keluar poly. Okay, poly here is the function file name. Okay, so if you remember, okay, apa yang saya cakap tadi, file name should be similar to your function name. Okay, so just biarkan je dia, jangan tukar-tukar example 1 ke tutorial 1 ke, tak payah. Okay, biarkan je dia file name as poly. And then click save. Okay, so the naming conventions ni sama macam you namakan you punya variable. Okay, you hanya boleh guna letter and cases and underscore. Okay, and then you should start with letters. Okay, and tak boleh start dengan numbers. And then it is case sensitive, so poly small cases here is different. If you ada dua poly file name, satu huruf kecil, satu huruf besar, it is different. Okay, now you dah create you punya function file. So I want to show you how you can call that function, use that function from the command window. Okay, so from command window, you just type in the function name, which is poly. Okay, and then enter the input for that function file. Okay, so input here is the value of x. For example, I want x to be 4. And then you hit enter. Okay, so bila you hit enter, you akan dapat the answer, okay, of this polynomial calculation. Okay, so the way MATLAB reads you punya instruction is poly 4 ni, maksudnya you assign value of 4 to the variable x that were used to calculate the output, to produce the output according to this expression. Okay, so you boleh check the answer. The answer is printed out to the command window as in the variable a and s here. Right. Okay, so while you are creating a function, it may be useful to allow intermediate calculations to print to the command window. However, once you complete your debugging, make sure that all your output is suppressed. If you don't, you'll see extraneous information in the command window. Okay, this basically means if you buat a very lengthy or more than this 1 or 2 lines of function file or script file, it would be useful if you, kalau you tak suppress ni lah, so you boleh check you punya each line tu whether it is appear correctly or not. Okay, so kalau you tak suppress by including the semicolon, at the end of you punya statement line or variable line or assignment line ni, okay, what happen is dia akan repeat. So output ni is repeated from this task lah. Okay, so every time kalau you ada banyak sangat calculation kan, so dia berderet lah dekat command window ni. Okay, so kalau macam nak kemas sikit lah, make you punya calculation, you punya coding tu more neat. Okay, you boleh letak this semicolon. Okay, lepas you dah debugging tu maksudnya you check lah you punya programming tu whether it works ke, dia boleh ada error ke dia tak ada error ke. Okay, that kind of things. Okay, okay, like that. Okay, so always remember the way you run you punya function, you call your function, you kena type in and then hit enter. Kalau you just okay, function ada ni dekat sini, lepas tu tekan je enter, tak ada apa lah. Okay, okay, next let's look at this another example which converts seconds to minutes. Okay, so in this example, function results equal sign fx, so result is x divided by 60. Okay, so this is to convert seconds to minute. Okay, you boleh try. So function result the input variable is only one, fx. Okay, and then this one convert seconds to minutes. Okay, and then do not forget to type in whatever, okay, dia punya expression or dia punya statements atau dia punya equation involved. Okay, okay, and then make sure you save. Okay, let's clear our workspace and command window. Okay, you boleh type help f, okay, yang ni, to identify with what is the function file f is all about. Okay, tapi ni hanya akan keluar if you include the command dekat you punya function file. Okay, kalau tak ada, for example tak ada kan, okay, and then you type help, okay, nothing lah, no help found, tak ada apa yang keluar. Okay, so it is recommended lah for you to include command, deliberately command you punya function file. Right? Okay, so now you should know that functions can accept a variety of input arguments. Okay, so it can be the input variable or input argument can be numeric values. Okay, numeric values yang macam saya dah tunjuk sebelum ni kan, yang poly4 ni. Okay, it can also accept variables, scalars, and also arrays. Okay, vector lah. Okay, so let's try all these category inside this fx function. Okay, f function. Okay, so Kita try for scalar dulu. So F60, hit enter. So you akan dapat A and S tu dia punya answer variable. Okay, and then you can also define vector of x from 1 to 5. Okay, and then this is how you execute fx. Okay, tapi make sure, okay, kalau you nak buat operation for array, okay, make sure you masukkan this element by element wise yang dot operator ni. Alright. Okay, so now let's take a look at a few example of function files that MATLAB can handle. Okay, so these are example of functions with multiple inputs and outputs. Okay, recall the remainder function. Okay, remainder function ni is a type of a built-in function. Okay, the remainder function, okay, the purpose is to calculate the remainder in a division problem. Okay, so usually it require you as a user to supply the input of the dividend and the divisor. Okay, so in this example, if you type in REM, okay, REM is for the remainder, for calling that remainder function 53 ni. Okay, ini maksudnya calculate the balance of the division between 5 and 3. So 5 bahagi 3. Okay, so the answer here is the balance for that division problem. Okay, this is the syntax how to call the remainder function. Okay, as you can see, this function here has two inputs. And answer ni is the only output. Okay, so it requires two inputs but only produce one output. Okay, so here's another example. Okay, that show that a user-defined function could be written to multiply two vectors together. Okay, so we have this function definition line. Okay, this is the function body lah. Okay, so the function definition line akan start with the function word, and then this is the output argument, and then this is the function name, and then this is the input arguments. Okay, and then this is the command of the function. Okay, so this function, okay, required two inputs. Okay, more than one inputs. Okay, and then for each of the inputs ni ada dua inputs kan. Okay, all the two inputs here are in a vector. Okay, so x here is a vector, an array lah, from 1 to 5. Y is a vector from 5 to 9. Okay, so output, this is the function body. Okay, output here, the output ni dia akan produce the multiplication between vector x and vector y. Okay, so make sure you include that dot operator to indicate element by element operation. Okay, let's try the example in a MATLAB file. Okay, so I'm going to create a new function file. So here function output is equal to G xy. Okay, and then you boleh include the comment section. Multiplication of x and y. Okay, another note. Okay, note ni is not only for you tapi untuk other user that could use you punya coding or you punya programming. Okay, x and y must be in same size. Okay, so here is the function body. Okay, and then save. Okay, so now you have to define the x and y vector. Okay, so we define the x and y vector in the command window. Okay, and now we want to perform the multiplication between vector x and y. Okay, so you can see that when you define vector x and y in command window and then you call for function g, okay, a vector of output values, okay, a and s ni is printed out in the command window, and also it was there in the workspace window. Okay, so if you look closely at you punya function file, only x, y and a and s is available in the workspace window. Okay, although dekat sini you nak define intermediate variable of a here. Okay, although calculation of a is performed, but only the output from this function is the variable, okay, that we have named as output. Okay, so output here is dia punya hasil multiplication of this matrix. Okay, but still one variable. Okay, so here, although our output is a matrix that contain various number, it's still considered as one variable. Okay, so this is, although dia punya output ni adalah a matrix, okay, yang ada 5 elements here, okay, but it's still considered as one variable. Okay, so moving on. Okay, here. Okay, this is another example of a built-in functions with multiple outputs. Okay, so recall the max function. Okay, max function is when we want to identify the maximum value in a matrix and the element number at which the maximum occurs. Okay, so this max function will return two results. Okay, for example, okay, let's look at this example. You have a matrix X of 3 elements, and then you call for max of X, okay, to determine the maximum value. So the maximum value is 5. Okay, so unless you decide atau you specify, okay, the two results that you want, okay, MATLAB will only akan produce one variable for that maximum function. Okay, so to do that, you have to specify inside this square bracket. Okay, A, B here. Okay, this you boleh tukar, change into other useful, meaningful name. Okay, for max function. Okay, tapi dia akan indicate the first field ni, A ni akan let you know the maximum value, whereas the second field here akan let you know the element number. Okay, so for this max function, okay, the maximum value is 5, which occurred at element number 2. Okay, so let's look at this example. Okay, so here we have a user-defined function which calculate the distance, velocity and acceleration of a particular car for a given value of t, assuming all three parameters are initially 0. Okay, so this is the function definition line. It has 3 outputs, okay, and 1 input arguments. Okay, so this is the function body. So this function body ni kita akan include the equation to calculate each of this output. Okay, acceleration, velocity and distance. Okay, and then although this function return 3 output values, okay, although kita set dia to produce 3 output values, but if you don't ask for all 3 results, MATLAB will only return the first value. Okay, so for example, okay, kita boleh tengok in our MATLAB. Okay, so function distance, velocity and acceleration. This is our file name, motion, and we only have one input argument. So this one you boleh calculate function to calculate distance, velocity and acceleration. Okay, boleh sambung lah. Okay, and then kita include our function body, which is the equation involved. T to the power of 3 divided by 12. Okay, lepas tu save. Okay, make sure file name ni sama dengan function name. Okay, and then save. Okay, so now let's clear. Okay, so this is how we execute the function. We call that function motion. Okay, and then type in your input argument, for example motion 10. Okay, this is t equals to 10. Okay, so when you hit enter, MATLAB akan produce one result. Okay, result ni dia store dalam variable answer here. Okay, tapi kita nak the value of each output ni kan, distance, velocity and acceleration. Okay, so to do that, you have to ask for all the three results. Okay, caranya adalah distance, velocity, acceleration equals to, okay, this is you call dia punya function name. Okay, hanya dengan ini barulah you boleh dapat access to all the three different outputs that you specify inside you punya function files. Okay, so recall the size function. Okay, size function of the built-in function. Okay, although at first this function looks like it returns two values, but it really returns a single array with two elements. Okay, size function ni is to determine the size of a matrix. Okay, dia akan return as 2, 3 here. So 2 means the number of rows and then 3 is the number of columns. Okay, although dia ada 2 ni, tapi dia sebenarnya adalah considered as one variable, okay, with 2 elements. Okay, so let's look at this another example. Okay, here is an example of a function with 2 inputs. This is a type of user-defined functions. Okay, so I hope by now you boleh faham that function, okay, not only requires satu input atau satu output. Okay, dia boleh juga ada multiple input and also multiple outputs. Okay, so this is an example of a user-defined function that use 2 inputs and 1 output. Okay, so this is for the Pythagorean theorem. Okay, so kita nak calculate this hypotenuse of C. Okay, when the length of A and B are known. Okay, so here you tengok dekat this triangle here, the input arguments is A and B. Okay, they actually small case lah. And then the output argument is C. Okay, this is the function body. So now you nak transfer all this information of this problem here inside the function file. Okay, so was here. Okay, so start with the function and then this is the output, Pythagorean. Okay, tak semestinya you nak letak nama ni apa-apa pun boleh, as long as it is meaningful. Okay, so this is the function body. Make sure you masukkan dia punya input argument. So ada 2 input argument dia, A and B. Okay, and then end you punya function with the end statement. Okay, nampak senang kan? Memang senang pun. Okay, so to execute this, kita akan call the function name. Okay, to make sure you jangan salah eja lah you punya function name tu. Okay, let's say kita punya A tadi 3, B kita 4, and then hit enter. Okay, okay, and then this is an example with 2 inputs and 2 outputs. Okay, sama je macam yang previously, except that now input dia ada 2, output pun ada 2. Okay, so where is it? Area volume here. Okay, so bila dia ada 2 output, okay, you kena enclose dia guna this bracket. Okay, kalau yang Pythagorean tadi ni, dia actually optional. You tak perlu nak enclose dia dalam square bracket pun is okay because dia hanya 1. Okay, tapi bila dia lebih pada 1, you should enclose it inside this square bracket. Okay, and then this is how you calculate the area and also volume. Okay, and then to call that function, okay, from command line, Okay, let's try 2 and 20, and then you will get the answer. Okay, dia hanya satu unless you specify you nak dua. Okay, so kalau you nak dua, you nak tahu the value of area and volume, okay, you have to specify dia. Okay, so that's the difference. And then macam mana you nak apply the knowledge lah. Okay, so macam ni baru you akan dapat the value for area and volume. Okay, otherwise kalau you just call the function with dia punya input argument, okay, MATLAB will only produce the first output, which is the area. Okay. Okay, and then comments. Okay, you should comment function liberally just as you would any computer code. The comment lines immediately after the first line are written when you query the help function. Okay, yang ni saya dah tunjuk previously lah. So kalau you help, you type help, and then what is it? For example, kita nak try motion. Okay, what happen is, okay, dia akan print out the comment yang you include dekat function file tadi, kan? Okay, so there are also functions that require no input or no output. Okay, the examples are this star function. Okay, this is a function to create this star plot. Macam ni lah rupa dia. Okay, so kalau you notice here, input dengan output dia tak ada variable. Okay, so just nak let you know that it is possible for a function with no input and output arguments. Okay, so if you try to set the star function equal to a variable, for example, yang ni kan, okay, and then bila you nak ni set function star ni equal to a variable, you akan dapat this error statement, okay, dekat command window. Okay, it is because the star function does not return anything. Okay, so dia tak ada, there's nothing to set a ni equal to. So that's why MATLAB akan return this error statement. Okay, you boleh try on your own time. Okay, so here is how you can determine the number of input and output arguments. Okay, so these two built-in function and nagin and nagout ni actually number of ARG argument input. This is for number of input argument. This is for number of output argument. Okay, so nagin determine the number of input arguments and nagout determine the number of output arguments. Okay, so you boleh apply this on either user defined function or a built-in function. Okay, so this is an example. Okay, you nak determine input argument, number of input argument for remainder function. Okay, dia akan produce 2. Okay, meanwhile the nagout akan produce 2 juga. Okay, so remember that input to this function is represented using a string. Okay, so the nagin and nagout ni dia different from other built-in and user defined function because dia punya input tu is represented using a string. Okay, lain kan? Okay, bila you nak guna? Sebab apa you nak tahu the number of input and output arguments? Okay, so you can use that in and knock out information in your programming to make your functions more versatile. Okay, for example, the surf function, 2D matrix ni semua surf function ni yang kita tengok dalam plotting chapter previously. Okay, for example, the surf function accept a variable number of arguments. Okay, so you can either surf z ni, okay, dia hanya perlukan satu argument, input argument. Okay, so surf satu input argument ni untuk plot 2D matrix lah. Kalau 3 input argument ni to plot 2D matrix Z against the X and Y coordinate 3D lah, 3D. Okay, 2D surface. Okay, so when a variable number of argument is allowed. Okay, so this is an example, okay, to determine number of input argument of surface function. Okay, so if the answer ni dia written as -1, it means that there's a variety number of inputs possible. Okay, you boleh specify input for that surface function more than one lah. Okay, kalau -1 maksudnya ada a variety of input arguments available for that function. Okay, so this is an example where the number of output argument is used inside that function. Okay, so function star tadi. Okay, so when used inside a user-defined function, knock-out determines how many outputs requested by the user. Okay, consider this example. So here, if we use the knock-out from the command window, as in knock-out is to *1. Okay, knock-out of *1. Okay, answer adalah 1. Okay, so MATLAB tells that one output is specified. So if we call the function as *1, nothing written on command window, although the plot is drawn. So if we set *1 equal to a variable, as in x equals to *1, a value for x is written based on the if statement embedded in the function, which use knock-out to determine the number of output values. Okay, dia basically dia guna if else statement ni. Okay, mula-mula with this function, okay, apa yang kita dapat hanyalah this star plot ni. Okay, so if number of output argument is 1, okay, so this statement line ni akan printed out lah, dia akan keluar twinkle twinkle little star. Okay, so otherwise if dia bukan 1, sebab tu dia if lepas tu n. Okay, kalau bukan 1 dia tak akan keluar lah this statement twinkle twinkle little star, right? Macam ni dekat command window. Okay, so if *1 is not set equal to a variable, the *1 is drawn but no output is written. Dekat sini tak ada output. Okay, so if *1 is set to a equal to a variable, so x equal to *1, okay, this twinkle twinkle little star ni dia akan printed out dekat command window. Okay, lepas tu and the output is stored in the workspace. Okay, this is another concept, okay, that is important in the function chapter. Local and global variables. Okay, so basically all the variables in the function file are local. Okay, mean that it only have meaning inside that function. Okay, so variable ni they include the input, output and also any other variables that are assigned within the function file. So these variables are then used in the calculations within the function file and will never be confused with variables called with the same name in the main script file or other function. It is possible, however, to make a variable common. Okay, means you boleh guna that same variable in different function files and perhaps in the workspace. Okay, by declaring the variable global both in the function file after the definition line and in the script file. Okay, so that mean you declare the variable as in global. Okay, so basically if you set For example, you assign X equal to 1 dekat command window. Hanya command window je boleh access that information. Okay. X equal to 1 is only accessible to the command window, not in the function file. Okay. So, dia sama macam tu juga kalau you set Y equal to 2 dalam function file. Okay. Hanya function file je boleh access that information. Command window and also workspace window tak boleh guna that information. Okay, so the only way to communicate between functions and the workspace is through the function input and output arguments. Okay, so we'll see the example. Okay, here we have a function file. Okay, so x, y, output, x, y, output, and a are the local variables to the g function. Okay, dia dalam function g ni aja. So bila you execute this function g, okay, nak execute function, you type in g1020 ni kan. Okay, input dia ada dua kan. Okay, so yang answer variable ni dalam workspace window ni is only available for workspace and command window je. Okay, yang function file ni tak boleh access whatever yang ada dekat dalam workspace dengan command window. Okay, so in this case, dekat command window atau workspace window, okay, hanya answer is the only variable created. Okay, let's look at this example of distance t. Okay, so distance t ni, dekat dia punya calculation of results ni, it requires the information of g. G ni constant kan. Okay, g ni is the gravity lah, value kan. 9.8 meter square second square. Okay, so G must be defined in the function file. Okay, so that dia punya calculation can be used. Okay, let's look at the example. Okay, so here the example of distance function. Okay, you can see here G is defined inside the function file. Okay, so let's try execute with the defined G inside the function file. Okay, so kita boleh execute okay, distance 10. Okay, so kita akan dapat the answer. Answer ni is stored inside the workspace under variable name ans. Okay, what if you do not provide the information of G here inside that function file? Okay, so kita cut. Okay, save. Okay, yang ni kita clear dulu. Okay, and then you provide it here in the workspace window. Okay, maybe you rasa okay, saya dah provide dekat workspace window ni, patut boleh lah kan buat calculation. Okay, let's try. Boleh ke tak boleh kan? Okay, so you will get this error. Okay, undefined function or should distance ni lah. Okay, the error should be not enough input arguments. Okay, this is because although you bagi tahu that information of G dekat workspace window ni, tapi function ni tak boleh guna information of G ni tadi. Okay, dia tak ada access to the workspace window. Okay, so the only way is you kena provide je. Okay, through input arguments, baru dia boleh guna that information. Okay, faham? Okay, so now kita boleh clear balik, and then tengok dekat workspace window hanya ada ans tapi tak ada G. Okay, but even tak ada G pun you still boleh calculate the distance equation, okay, from this function distance, okay, provided that it is supplied inside your function file. Okay, so the only communication that could occur between function file and also command window is through the input arguments, and the only way they can deliver information is through the function output. Okay, information tu hanya boleh deliver through the output result calculation here, and then macam mana you nak bagi tahu information ni is through the input argument. Right? Okay, so ni saya dah demonstrate. Okay, so now let's look at how we can access the M file code. Okay, so now you should know that the function provided with MATLAB consists of two types. Okay, the first is built-in and code is not accessible to us, and the second type is consists of group of function M files, just like the ones that we have been writing. Okay, yang dalam example. Okay, so now you can use the type function to see the code in function M file. Okay, for example, you boleh type ni, copy ni, type file name. Okay, so it will inform you whether the function is a built-in or print out to the command window all of the lines in the M file with that name. Okay, you boleh try type sin and type max. Okay, for example, you type sin, type sin. Okay, dia akan inform you sin is a built-in function. Okay, you boleh try type you punya built-in function. Distance is a user-defined function. Okay, so dia akan print out the command window the whatever content of the function file. Okay. Okay, so you can try this type sphere. Okay, so type sphere dia akan keluar dia punya information. Okay, stored as a function F file. Okay, and then the type distance tadi that we just wrote previously, and then save in the current directory. Okay, I think that's all for the first part of user-defined function. So in next we'll continue with the anonymous and subfunctions, and also functions and all that that I mentioned earlier. Alright, that's all.